We often trust AI because it's accurate, but accuracy often hides the why. Explainability isn't just about performance metrics, it's about understanding how a model arrived at its decision. It's the critical bridge between statistical correlation and genuine human comprehension. Consider a deep convolutional neural network, tasked with image classification. It might predict dog. Grad-CAM, or gradient-weighted class activation mapping, doesn't just confirm dog, it generates a high-resolution visual heat map, overlaid directly on the original image, highlighting the exact pixels and regions the network focused on to make that dog prediction. Its core mechanism involves taking the gradients of the target class score. With respect to the feature maps of the final convolutional layer, then weighing these feature maps, this process creates a coarse localization map, effectively showing the salient regions that influence the model's specific output. In medical diagnostics, for instance, a model might detect a subtle tumor in an MRI scan. Grad-CAM then visually indicates to the clinician precisely where in that image the AI identified the anomaly. This insight is not merely for model validation, it builds critical trust, aids in confident clinical decision-making, and transforms an opaque suggestion into actionable localized evidence. Unlike simpler interpretation methods, which might provide a global understanding of generally relevant features across a dataset, Grad-CAM offers local spatial insight for specific image data. It meticulously pinpoints what part of this particular input drove this specific output. Traditional debugging merely confirms if an answer is right or wrong. Grad-CAM visually illuminates why the model perceived it to be right, or even why it might have been wrong. However, a crucial nuance: Grad-CAM maps are sophisticated saliency maps, not definitive causal explanations. An AI might inadvertently fixate on a background object or a subtle texture rather than the main subject for its classification. Misinterpreting these maps as direct causation can lead to false confidence and flawed conclusions about model reasoning. The cutting edge in explainability is moving beyond mere correlation to true causal understanding, often involving counterfactual explanations, but this introduces significantly greater complexity and computational cost. We must always understand the inherent limitations of our interpretability tools. Deploying advanced AI systems, especially in high-stakes domains, without robust explainability in Python, is essentially deploying black boxes. Understanding why a model behaves as it does, through powerful tools like Grad-CAM, transforms opaque, seemingly magical predictions into transparent, accountable, and ultimately, far more trustworthy AI. It fundamentally shifts the paradigm from merely knowing what the AI predicts to profoundly understanding how it arrives at that prediction, empowering truly informed human-AI collaboration.